All right, in our Unit 5, we've been working specifically on the midpoint formula. And the midpoint formula, we're going to look at both of our x values and put them into our formula here. We're going to take both of those x values, we're going to add them together, and then we're going to divide by 2 to find our x value. For our y's, we're going to take both of the y values from the given points, and we're going to replace them here into the formula. Just like we did with the x's, we're going to take and add the y's together and divide by 2 to find our y value. Our other formula that we've been working on is the distance formula, and in order to find the distance between 2 points, we're going to take our x values, and you can see here we're going to replace them into our bracket here. So underneath our big radical sign, and in our first parentheses, we're going to take the x values, and we're going to put both of them in, and this time in the distance formula, they get subtracted, and then they're going to get squared. And it is important to understand with these subscripts here that the order that I put these in does make a difference. So I have to make sure that if I put this x in from this point, and then I put this one in, like I did over here, then I'm going to have to follow that same direction when I do it also for the y's. So again, I'm going to take those y values and I'm going to replace them here into my formula. And then again, our calculator is going to help us out. I'll be able to subtract these y values and square them. After I do that, I'll be able to add these two together. And then finally, I'll take the square root to find my distance. For the next part of our DCA, there is going to be a little bit of a review, and it specifically talks about slope. So it may help you to remember what the slope formula is. If it freaks you out a little bit, though, we will show you how to do it on decimals as well. So I'm going to take my x values, and notice in this formula where my x values go. It's in a little different place than it was before. And similarly to the distance formula, I have to make sure that directionally I'm going in the same way that I'm going with my x's and my y's. So notice my two x values, they go down here at the bottom of the fraction and they will be subtracted. And then notice here again my y values, they're going to go right here, and again they will be subtracted to find my slope. The reason that we're wondering about our slope is, for instance, this. So I may see a problem like this on my DCA where I have a shape. So I have a shape here, it's a rectangle. Well, I'm trying to prove, is it really a rectangle or not? So they're going to give me these coordinates. And then what I need to figure out is, are these two distances from here to here, are they the same? Because they need to be in a rectangle. Remember, this is going to have a notch and this is going to have a notch, meaning that these two sides should be the same. The same goes with these sides as well. These sides also should be the same, or their distances should be equal to each other. So we've been working on distance, so that should be okay. But the other piece of it comes in the slope. Parallel lines have slopes that are the same. So for instance, these two lines right here should have the same slope. If they have the same slope, then I know that they're parallel. And in a rectangle, these two pieces should be parallel. Remember, it is a type of a parallelogram. The same goes with these two opposite sides. These should also be parallel to each other. So if I found their slope, either using this formula or graphing it on decimals would be okay too. These slopes should be the same. The last slope that I need to pay attention to is a perpendicular slope. In a rectangle, I need to have 90-degree angles. And 90-degree angles happen when I see perpendicular lines. So what it's saying is that the slope of this line right here, for instance, and the slope of this line right here should be perpendicular to each other. If these are perpendicular, then I know it makes a right angle. And an example of a perpendicular slope, for instance, if I have a slope of 2/3, I would have -3/2. Perpendicular slopes are both opposites, meaning one will be positive and one will be negative, and reciprocals. And if you remember anything about fractions, reciprocals just mean you flip that fraction. So this is an example, 2/3 and -3/2. One's positive, one's negative, and 2/3, if I flip it, becomes 3/2. So if I found, for instance, that this one had a slope of 2/3 and this one had a slope of -3/2, then I would know that they're perpendicular. If this was the slope of this guy up 2/3, and this was down 3/2, then I would know that those guys are perpendicular, which helps me prove that to be a rectangle.